Okay, right, so my name's Paul Fish. I work for the European Space Agency, particularly in the Climate Office. So we use satellites to develop long-term, multi-decade global satellite data records for key components of the climate. It's the fundamental basis of our understanding of climate, helps drive models to understand the future, and it's helping support implementation of the Paris Agreement, i.e. address climate change. Okay, so, right, that's me, we've done that. European Space, right, so the talk will be a quick review of who the European Space Agency is and what we do, a quick look at some satellite highlights that are giving information on the climate. Then I'll focus on some of the news items that ESA have produced that have landed with our audiences, so what's been popular and why, and show you what we've done. I'll then show you how to access ESA Media, and then if there are any data journalists or image journalists out there, I'll show you how you can get your hands dirty with satellite information. Right, so we're made of 22 member states across Europe. The flags are all at the bottom, and we pool our resources to do everything there is to do with space. So we produce launchers to get satellites into space. We look out into the cosmos. This is 6,500 light years away from where we are now. It's called the Pillars of Creation, and this is a photograph from 1995 from the Hubble telescope. It's where planets and stars are beginning to be born today. Okay, this is a picture from last year from the Webb telescope. You can see there's more definition. It's just an example of how our science and technology is cutting edge. A little bit closer to home, we have a mission with astronauts, so we're involved in human space flight. This is part of an Artemis mission where we're looking to get a manned base on the moon and maybe beyond. So we explore the solar system with astronauts. And that's the mission there. The second part of this module was generated by the European Space Agency, and the front was a NASA module. But all that's really boring. The cool bit is on my next slide, if I could get to it. There we go. Okay, so you've all probably used your mobile phone and probably used satellite navigation. So we're involved in your day-to-day lives with telecommunications, but that's not interesting. This is the cool bit. Ugh. Hang on, where's the animation gone on my slide? Was the cool bit, I've spoiled it now. How do we go back? Okay. So, I don't think the animation is going to work. Right, so using Earth observation satellites, we're monitoring the Earth. We've been doing it since 1972 across a whole range of variables that characterize what's going on. For those of you that don't know, the climate's made up of 55 variables. The European Space Agency is looking at 25 of those. So we're playing a major contribution. Those data help understand what's going on, so we're supporting our fundamental understanding of climate. If we don't do that, we can't work out how much we need to mitigate greenhouse gas emissions. So there's fundamental science to understand the climate. We're supporting mitigation, and we're also supporting the models that are predicting what future change is going to come our way so that we can act now. So it provides early warning. So it's all done with satellites. Okay, and we produce multiple of these. So this is an infographic of the satellites that ESA is developing that are related to Earth observation. Those in orange are to do with weather and probably aren't to do with today's topic. The blue ones are from a European program called Copernicus. They're the Copernicus Sentinel. So there are all the satellites, the workhorses, that are giving that global daily information of what's going on with our climate. And you can see we have 2025 here. So we have lots more in development. So you're going to see that constellation of satellites and the amount of information and imagery expand significantly over the next 5 years. And then my science colleagues are producing these green satellites. These are called ESA's Earth Explorers. They're the proof of concept, the novel satellites. Proof of concept, they haven't been done before. They're to test new technologies. So we have biomass, which is going to be launched in the next few years. That's going to be able to give a 3D picture of forests, so we can work out how much carbon's in the Amazon, for example, and how it changes. It's important to know those major sinks so that we can see where we are with atmospheric emissions. Aeolus has just been looking at wind currents globally. It's important to understand wind currents so we can understand where heat, energy, and water is moving around the climate, etc., etc. So there's lots of activity. And what we're producing are these things. These are all planet Earth, but they're the different variables of the climate. So we're looking at the atmosphere, the land, and the ocean. For example, we have changes in sea ice. For those of you who don't know, that'll be gone by 2050 in the summer. Major changes are coming our way. We look at greenhouse gases, so this is methane and CO2. The ozone hole, which is a really positive story, which I'm not going to cover, but that is a positive climate story that we have. We're looking at sea level rise, sea surface temperature, changes in the amount of carbon in the world's forests. All this information is important to understand what's going on now and what will happen in the future. We do that by getting satellites that we have today and combining them with satellites historically to create decadal-long data sets. It's a massive research endeavor. So this is to look at a variable called soil moisture. We put all these together into one data set, so we produce 30, 40-year data sets. That way we can pick out natural variability in climate change. The data are all used and inform and support the UNFCCC, the United Nations Framework Convention on Climate Change. That's the international body that drives the climate process. And all the data go towards the IPCC assessment reports, right? So we're informing global policy. Okay, a couple of examples of where the data is being used. And I don't know how to make that go round. It's supposed to animate. Right, okay, so there's something called the Global Stocktake that's going to happen at COP this year, where the UNFCCC will look at the state of our climate, how we're progressing in terms of reducing emissions and improving our sinks and sources of carbon. ESA is providing data in terms of greenhouse gases, fire emissions to the atmosphere, as well as what's being taken out of the atmosphere from the world's forests and world's vegetation. That will give us the first assessment of where we're at in terms of making progress towards net zero, getting this balance between what we're emitting and what we're taking out of the atmosphere. That will drive ambition at a national level on a 5-yearly cycle. So we're supporting the global stocktake and the Paris Agreement. We're already using satellites to help mitigation. This is my friend Sentinel-3. This gives daily global maps of methane, particularly from anthropogenic human sources. We can identify plumes from industrial facilities such as oil and gas, and we can identify where those sources are coming from. They're also really easy sources to tackle, so leaks in oil pipes, for example. So we use Sentinel-3, which gives coarse global resolution, with our friends Sentinel-2 and 3 to pinpoint where those emissions are, and we're helping already to reduce methane emissions. So 2021, we identified 3,000 plumes. Those plumes and those leaks were fixed, and that's the equivalent of the Netherlands' annual greenhouse gas budget. So we're already making massive differences. just show you some of the data that comes from that. So this is a methane plume on the left-hand side in an oil field in Algeria. You can see the plume here, very, very rough resolution from Sentinel-5P. Then we zoom in with Sentinel-3 to get a rough idea of where it is. And actually, that's where the emission's coming from. So go and fix that leak, please, is what's happening already. We're going to be doing the same with carbon dioxide. So we're covering the two major greenhouse gases, and we'll be able to target all those emissions. I told you I had a lot of slides. Right, so the news bit, this is what we're here for. I'm going to show you some examples of news where we've hit the spot. These are the popular news items over the last 18 months. It tends to be when we're combining the data with a major news event. So we've all been in lockdown and COVID. This is an animated map showing emissions of nitrogen dioxide. This is a tailpipe gas from fossil fuel combustion. And you can see before and after in the major cities. So look at Paris, Milan, and Madrid. And then we've got Lisbon down in the bottom right-hand corner just about. You can see where the emissions are coming from and where they're stopping during the lockdown. And we can show that using satellite data. Again, this is from Sentinel-5P. And it just illustrates what's going on in the world from satellite data. Nitrogen dioxide is it's involved in the climate. It's quite complicated, but it's a lovely visual to just show what's going on with a major news event, and it's climate related. Perhaps the next slide's got topical again with what happened yesterday. So we can detect these methane leaks. So this was a particular popular item from last year when the Nord Stream ruptured due to a seismic event. However that happened, I won't comment. But we can see from optical satellites, so like cameras in the sky, you can see the ripples, the bubbles, but it's cloudy where this was. This is between Denmark and Sweden. So we didn't get very many images because there were too many clouds and you can't see through them. We use a technique called satellite aperture radar. We can see through clouds and you can see the ripples that are appearing on the surface. So you can work out when it happened if you go back in the record. And then with our friend Sentinel-5P and another satellite called Greenhouse Gas Sat, you can actually see the plume and estimate how much emission came from that particular leak. Okay, so maybe we've all been noticing the climate changing. When we have extreme weather events, those are particularly popular with our audiences. So this is a map of Europe. It's land surface temperature. Okay, so this was back in July. We were getting record temperatures, particularly in Italy. You can show the temperature difference and identify where the extremes occur on whatever geographical scale you like, whether it's city, regional, or continental. It was very successful. If you do ever want to report land surface temperature, I offer you a word of caution. Land surface temperature is the skin surface of the Earth. It's not what weather forecasters use to say what the temperature is. They're related, but they're different. So we learned our own lesson that we have to be very cautious when we're talking about temperatures and land surface temperatures, because that's not weather forecasting. So we might be getting record land surface temperatures, but it's not necessarily the same as what the weather forecasters will be saying in terms of major weather events. Last year we had drought. Drought was a topic last year. This is an image of the River Po. It's Italy's longest river. In 2022, I don't know if you remember, but we had severe droughts in southern Europe. And you can see the river change colour between 2020, which is now, and 2022 when there was a drought, and that was causing problems with water availability. This is from my friend Sentinel-2. That was a particularly popular news story. While we're having droughts in Europe, we're having major flood events in Pakistan. So this was during the monsoon where they received rainfall 10 times higher than usual. not just in a local area, this covered a third of the country. It killed over 1,000 people and affected 1 in 7 Pakistanis. So they're major events that we can show quite quickly on a large scale from space. This particular event is actually interesting from a research point of view. So you have rivers on ground, you also have atmospheric rivers moving water vapor around, and there's a hypothesis that that behavior is starting to change and intensify. The image on the right-hand side, if it animated, would show you how water vapor moves around the Earth, and that's a 30-year data set that we produced to help try and address those questions. Water vapor is a greenhouse gas, if you didn't know, and that increases 7% by every degree of warming, and it amplifies the issue around CO2 and methane emissions. So it's a really important part of the climate system to understand from an extreme weather point of view, but also from amplifying climate change. I don't know where I need to point. Okay, another one, just to show how we're showing off our imagery. So we've got a slider here which will show you before and after of Utah's Great Salt Lake. This reached minimum levels or record levels from 1800s in 2022. So that's what it looked like in 1985. And that's what it looked like in 2022. There was a mega drought in Southwest America. So there were 2,200 kilometers square area of lake bed revealed. That's the equivalent to the area of Tenerife. But it's a very stark visual example of what happens with weather extremes. So we show off extremes. Actually, we're a science-driven organisation. Again, my animation isn't working, I apologise. This is just an example to show you what we do in terms of science. So this is a map of an area in the Amazon, and these 2 square patches have been deforested but are starting to regrow. What we found was actually when you have forest regrowth, you never get back the carbon that you've already lost. You only get back 25% of that carbon. It's a really interesting paper. It's really important because the key message for policymakers and the Brazilians is that you should protect your forests. And I've mentioned science, I've mentioned adaptation, mitigation. We're also looking to support adaptation, how society needs to change to the effects of climate change. This is a map, a diagrammatic from the top of the globe. This is the Arctic area, which has got a lot of permafrost, so frozen ground. As the atmosphere is warming, that's starting to thaw, and it's destabilizing the land surface. So things like roads, factories, diesel plants that are right next to the Arctic Ocean are all starting to subside. And I don't know if you remember the Norlisk diesel leak in about 2020. There's massive problems with land subsidence. So we've used our data to show what's been happening to date, and we've shown an increase in permafrost thaw. By 2050, we predict that 55% of the infrastructure and the communities in the Arctic will be at threat of land subsidence. Okay, so how do you access ESA stuff? So this is our website, esa.int. My animation isn't going to work. No, it isn't. Okay, so you go to the hamburger at the top. Come on. Okay, and if you go down to the bottom, you can access all of our images and all of our videos, whether that's an animated GIF of recent events. They're all available, they're all free and open to use. That's just an example of the images that you might get. If there are any broadcast journalists here, we have high-resolution broadcast documentaries that are available with a whole catalogue of B-roll in several languages. The link is at the bottom, and hopefully these slides will be available to you anyway. And we also have a media team. So you can subscribe for press releases and embargo material. That will include all the space stuff. So if you're a climate specialist, that might not be specific for you. Go to the contact form and we'll get you onto a climate media list if you want to hear from us. And there's the email for our media team if you have a request for a spokesperson, some information, or on a case-by-case basis if you want a specific image or specific visualization from us, although it's on a case-by-case basis. Right, getting your hands dirty. So if you wanted to get some images from satellites yourself or play with the data, here's a couple of tips. So I mentioned Copernicus earlier. So there's a website called the Copernicus Data Space Ecosystem. There's the link. That will give you access to a whole range of tools where you can play with images over various timelines, choose your location, choose your satellite, so you can actually get the data that's coming from the satellites almost on a near real-time basis. There's also access to all the climate data records and tools and APIs, so you can get the data and play around with visualizations. So I'll just give you a quick run through. Doesn't want it. There we go. Okay, so this is the browser. I'm not an expert on all this, but I can do it, so it's not that hard. So you just search your location. I've chosen Odemira, which is, I think, south of where we are. You can choose your time range, and it'll give you a series of images over that time range and location. I chose this one because there was a heat wave and a series of fires. So I chose the satellite Sentinel-3, which is an optical satellite, and looked at the area. So you can get a pretty good picture just straight off. You can zoom in as well to get clearer pictures. You can also start telling stories. So I chose a different band, like a false colour. So that will show me whether the vegetation's alive or dead. Red is alive, dark is dead. So you can actually see where the fire, a few days later, what area it had affected. So you can start building stories up with these sort of tools quite quickly. This is what our colleagues did. They got the same images, they did a little variation. So they got the optical image, which gives you the smoke and the land, and then got in shortwave infrared, so you could actually see where the active fires were. Really impactful. Right, I'm going to run through these. We have heat waves. This is Sicily. You can easily get these if there's a heat wave event. It could be a city if you're interested in urban heat blobs, for example. That's where Mount Etna is, which I thought was interesting, how the mountain, which might be high, is actually quite hot. Anyway, it's just an illustration of what you can do. You can also look at the gases that are being emitted around. So if you wanted to talk about human health and climate, you can look at air pollutants as well. This is an image of Madrid looking at methane concentrations. Sometimes the pictures are just beautiful. If you ever go onto our website, go and have a look at the algal blooms. So this is the country I'm from, the UK. This is the North Sea, and you're getting these blooms of algae, so phytoplankton. They're important because they affect, well, they're a food source, a marine food source. They can affect fisheries, they can affect tourism because they're toxic. From my point of view, they suck carbon out of the atmosphere, so they're interesting from a climate point of view. But you could just get beautiful images, and if you zoom in on those and look at them in different wavelengths, they look beautiful. So that's playing around with the images. You can access climate data on a whole range of variables going back 50 years to do trend analysis or near real time, and there's 3 places where you could get them, probably increasing importance from your point of view. So I'm from ESA. What we do is we develop the prototype, the first go at the data set. So we produce the new stuff with the latest algorithms. It's the most recent, but it's not operational, so it won't give you what happened yesterday. So we've just done the R&D. What we do is we develop that and then transfer it to 2 other organizations. EUMETSAT and the Copernicus Climate Change Service. So this is where you'd probably need to focus. You can get data on meteorological events, climate and ocean satellite data from EUMETSAT, which are good. If I were in your shoes, I would probably be going to the Climate Change Service, the CDS climate.copernicus, the climate data store. There you'll get lots of tools that look at past, present and future climate change. The range of tools there are focused at scientists, policymakers, but also members of the public. So you don't need to necessarily be an expert. So if you want to get your hands dirty and access the data to create infographics, etc., that's a good source for you. Final slide. If you do want to get your hands dirty, if you want to get the slide to move forward, there we go. I'm running a competition at the moment. I'm inviting data journalists, educators, creatives, members of the public to get hold of the data and create their own visualization. We've created a few ourselves, and we're inviting people to submit their own, and the winner will display at the Conference of the Parties COP meeting in the UAE this year. So you might, if anyone here wants to submit anything, you might end up getting it shown to Joe Biden or Ursula von der Leyen, thank you. We'll also invite the winner over to our data visualization suite near Rome, and 10 runners up will be added to the gallery. So if you want to increase your own profile, if you're a data journalist, please do. The judges include Ed Hawkins, who created the Show Your Stripes data set, and a Der Spiegel journalist who we're working with called Matthias Stahl. Deadline's 20th of November. Thank you. And has anyone got a question? Sorry, the animations didn't work. They look great. Look great on my computer anyway.
Thank you so much, Paul. Yeah, so we have time for maybe one or two questions. Apologies for the animations in your slides. I'm sure I must have broken it somehow. I just wanted to ask quickly, before I open up to the audience, about licensing. You know, if people want to use the data, the images, you know, is that available for commercial use? What's the kind of licensing arrangement?
Yeah, it's open and access. It's open and free access for researchers. So using the images, for example, they're all on a Creative Commons license, CC BY, I think it's called. The data for media will be free and open access. If a business is looking to develop a climate service off it, there are more commercial implications. I've got to be honest, I'm not sure on that. But in terms of Copernicus, the general principle is that the data and the images are open and free. So from a journalism point of view, that will be fine.
Okay, thank you. Does anyone have a question? I'll come here and then the lady there.
Hi, thank you. What's the most exciting thing that's going to come up in by 2025? Like, concretely, what are you expecting the most?
Yeah, usually when something cool's coming up, it usually is a piece of research that's going to show that the climate's going to get worse. Actually, the big changes that you're going to see with satellites are the ability to pinpoint where human emissions are coming from. Right, so from space, monitoring greenhouse gases in the atmosphere, we've not, until relatively recently, been able to determine whether it's come from a biogenic source, so let's just say methane from wetlands, or if it's come from a factory. Sentinel-3 and then CO2M, the anthropogenic CO2 mission, can identify hotspots. So we can overpass a city and work out where the emissions are coming from human activity. So that's helping us target where the emissions are coming from, so we can do something about it there and then, but also track the effectiveness of the policies that are trying to reduce those emissions. And at a national scale, how are we doing in terms of staying within the emissions cuts that they pledged? We add those all up together, and hopefully we're going to make some collective progress. So for me, it's a technology around CO2M that's going to be the really cool thing.
Yeah, here, sorry.
Hello.
Hi. Yeah, so I have a question, actually that's related to what you just said. So I work for an NGO, it's called Climate Arc, so we work to match up like finance data and climate data because
Yep.
those sectors don't understand each other. So to try to improve investment based on where it's like where it should be going.
Yep.
So what's the best way to work with corporates on this? Because I worked with ESA data and Copernicus like in my own past, but just wondering, yeah, like what's the best way to, because ESA is, you know, state-based and understandably like emissions, et cetera, are divided by country and those units, but yeah, how do you, is there a link up to the financial system and corporates as well in general, and how we could work to visualize that data?
Yeah.
Thanks.
Yeah, okay, so we produced the long-term data, and historically we've been servicing the needs of the science community. We need to sort the problem out though, so we're evolving. So we're helping with mitigation, and we're also helping with adaptation. So we're helping to provide the tools to monitor progress in terms of sorting out climate change. So, for example, we work with the World Bank on global development assistance. So Earth observation is used to provide or support indicators of change, so that you can track how far we've progressed with our topic against the financial implementation. So let's just take urban heat waves as a random example. So we're expecting more intense and severe heat waves as we go into the future, particularly in an urban context. If we're funding green and blue infrastructure, so parks and water in cities, to prevent those heat waves peaking, we can actually link the heat wave event through land surface temperature with the financial investment. So we're tracking how we're progressing in terms of solving the problem and how effective a bang for buck we're getting.
I think we have time for just maybe kind of one or two very, very quick questions.
Yeah.
There's one here, and then there's one more. Okay, maybe I'll group them. We'll just
Yeah.
have two. Really, really quick.
Hi, I'm Umit Öztürk, coordinator of Euro-Mediterranean Resources Network, Euromed, in Brighton, in UK. I wonder if you work with international organizations, scientific and cultural organizations, for instance, like UNESCO. If you do you just supply data and ask them to analyze, or do you work together on analyzing other aspects, also cultural aspects as well as scientific aspects of climate change, for instance, climate-driven migration, climate refugees, which sometimes may lead to formation of some new list of endangered cultural heritage aspects in given area? Thank you.
Yeah.
I'm going to group the questions, so I'll just have one more.
Make it
Sorry,
twice as hard for me.
Thank you. My question goes in the same direction. If there are cooperations with other entities who have satellites, like the Chinese, the India,
Yeah.
and the US.
Yeah, right, so that one's quite easy. So ESA produces their satellites. Actually, the space agencies all work together. So these 30-year data records that ESA's producing, we're taking ESA data, JAXA, Japanese data, NASA, and what have you. So we get all the available data to make the consistent data record. There's no point putting two missions up that do the same thing, so we cooperate to tackle different areas. And then in terms of working with other international organisations, yes, we do. So, for example, we're trying to help address sustainable development goals. We work with the UN on that. We have a program called EO for Africa, where we're trying to use Earth observation data to solve or create climate services specifically to address issues around crop production, tackling heat waves, tackling drought as well. So yes, we do. We work with different organisations, and we use the data. We work on capacity building to allow the in-country individuals to take the data and use it themselves. And like I say, organisations like the World Bank. maybe we can have a conversation outside of this if you like.
Okay, thank you so much, everyone. Thank you. I'm afraid that
Thank
we've
you.
got to move on, but thank you so much.